Hello, today we're going to do lesson 5.3, finding equations of linear functions. Before we get to the finding equations of linear functions, I just want to make sure that we're still good about graphing linear functions in various forms, both in slope-intercept and also the point-slope form. So pause the video now, and I want you to take a minute or two just to plot some of these lines onto the graph on the side. Okay, so you may notice that graph of the first equation, the linear function, is in slope-intercept form. The slope is 1/4, and the y-intercept is 10. So this one, you can just graph by plotting 10 on the y-axis. So since this is a 12 by 12 grid, I'm going to put a dot on 10. I'm going to use the slope of 1/4 as positive slope, so it's up 1 to the right 4, up 1 to the right 4, make some points. Then going the other way, go down 1 to the left 4, down 1 to the left 4, down 1 to the left 4. Okay. And there is your horribly drawn line. Well, here's your linear function. Okay. And I'm going to label my starting point as A, and I'm going to label this as graph as equation A. Second one was also in slope-intercept form. The slope is 1/2. The y-intercept was 3. So for this one, you're going to start at 3 on the y-axis, go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Keep going until you can't get any more points. I'm going to label my first point as B. And then I'm going to go down 1 to the left 2, down 1 to the left 2. Keep applying as many points as you can. Okay, and once you have all those points plotted, you can then draw your nice straight line. I'm doing this with a pen, so I don't have a straight edge like you would have. Okay. Letter C, that equation is written in point-slope form. So remember, when you're dealing with point-slope form, the number with the x in parentheses is going to be our x-coordinate of our point, and the number with the y is going to be our y-coordinate. And remember, you have to change the sign. So the point that we're actually going through is -10, comma, +8. You have to change the signs for the point that you're going to start from. And the slope is -2/3. So instead of starting on the y-axis, I'm going to start at -10, comma 8, which is right here. I'm going to label that point as C, just because I'm dealing with the equation in letter C. And the slope is -2/3, so down 2 to the right 3, down 2 to the right 3, down 2 to the right 3. So it's going to intersect the other graphs, but we're not really worrying about the intersections right now. We're just graphing multiple lines on the same graph. Down 2 to the right 3, and there's all the points for that equation. So I'm going to take my straight edge and connect those points, and there is equation for line C. And letter D is also in point-slope form, so the point for that line is going to be at -2, -6. I'll write that a little neater. -2, comma, -6, and the slope of that line is 5/3. Okay. So I'm going to start at -2, -6, which is right here, and I'm going to use the slope of up 5 over to the right 3. Up 5 to the right 3 is right there. And by the way, I'm going to label that first point as point D. That way I know exactly where I started from. Up 5 to the right 3. Up 5, 1, 2, 3, 4, 5 to the right 3, and so forth. And then going the other way, I can go down 5 to the left 3 one more time. Okay, and then I'm going to use my straight edge and connect those points for equation D. Okay, so check those. Let's go on to the next ones. So for number 2, these are all written in using function notation. So again, take a minute or two to graph these 4 functions onto the same axes on the right. Pause the video to do that. Okay, so let's check your work. So the slope of first function is 3/2, and it's written in slope-intercept form, so the y-intercept is going to be -8. So I'm going to start at -8 on the y-axis. And I'm going to use the slope of 3/2 to go up 3 to the right 2, up 3 to the right 2, up 3 to the right 2, plus as many points as you can. Oh, come on. Sorry, my pen is not letting me graph very well. It's making me select things. Okay, so this point A, the starting point. Here's my graph. Okay, and extend it all the way up to there. And I'm going to label this one as f of x because that is the name of this particular function. Letter B is in actually point slope form, kind of. Okay, remember for this one, what you have to do is subtract the one from both sides to make it equal to in point slope form. So you can easily see what the slope in the point is going to be. So the point in this equation is going to be positive 3, comma positive 1, and the slope is negative 2/5. So I'm going to start at positive 3, positive 1. I'm going to label that as B. And it has a slope of negative 2 over 5, so negative 2 to the right 5. Negative 2, I can't plot that one anymore, so let's go to the left of it. Up 2 to the left 5. Up 2 to the left 5. Up 2 to the left 5. Okay, I have all my points. I just got to draw my line. And I'm going to label that as g of x, because that's what that one is called. Letter C is written in slope-intercept form, so the slope is easily seen from the equation, which is negative 3 over 1. And the y-intercept is located at negative 1. So I'm going to start at negative 1 on the y-axis, which is C. And then I'm going to plot more points by using a slope of negative 3 to the right 1, negative 3 to the right 1, and negative 3 to the right 1. And then going backwards, up 3 to the left 1, up 3 to the left 1, up 3 to the left 1, and there you go. And then connect those points, and you have, oops, using a stylus pen on this iPad is not the easiest thing in the world, especially when you're dealing with small graphs like this, right? So this is h of x. Okay, and letter D is written in point slope form, so you just got to rewrite it so it's a form that you can easily find the point. So subtract the a from both sides to write it into the point slope form. So the point that we're going through is positive 2, positive 8. Remember to change the signs. And the slope is 3/4. So I'm going to plot 2, 8 as my starting point, which is right here. And I'm going to label that as point D. And I'm going to use a slope of up 3 to the right 4 to plot more points on my line. Down 3 to the left 4. Okay, that's already a point on a line, that's good. And then down 3 to the left 4. Down 3 to the left 4. Okay, and I'm going to draw the line. I'm going to label it as P of x, because that's the name for this function. So check your graph, see how you did, and then let's move on to the next examples. So before we get to writing the equations of linear functions, I just want to do a little bit of practice with slope formula. So remember, slope formula is the difference between the y's, y2 minus y1 in the numerator, divided by the difference in the x's, x2 minus x1. So for each of these, you got to find out where x1, y1, and x2, y2 is. So we're going to let the 2, 5 be the first point, and 11, 11 be the second point. Plugging into the slope formula, y2 is 11, minus y1, which is 5, over 11, which is the x2, minus 2, which is x1. Okay, just plug it in, and then you just got to reduce it. 11 minus 5 is 6. 11 minus 2 is 9, so reduce that. Always reduce if you can by a factor of 3 in this case, so slope is positive 2/3. So go ahead, just pause the video for a second and try letters B, C, and D on your own, and then we'll go through them together. Okay, so for letter B, It's going to be 5 minus 1 over negative 6 minus 4, which gives me 4 over negative 10, which reduces down to negative 2/5. And typically the negative sign will go in the front or on the top. So if it's in the bottom, just move it to the top and you'll be fine. Or move it to the front and you'll be fine. So negative 2/5 for letter B. For letter C, negative 3 minus 8 over 6 minus 0, 6 minus 6, which gives me negative 11 over 0. Now here's an interesting thing, because you can never divide by 0. What we're going to say, there is a slope here, but it's going to be something called undefined. Okay. If I were to plot those points, 6, 8 is right here, 6, negative 3 is right there, it's a vertical line. Vertical lines do not have a slope that can be represented by a number, because there is no steepness to it. So we're going to call that, any vertical line, an undefined slope. So for letter D, so negative 4 minus negative 4, negative 1 minus 9. Now some of you might have written as negative 4 plus 4. That's perfectly fine, over negative 1 minus 9. Either way, we get 0 over negative 10. Now 0 can be divided by any number, so the slope of this one's going to be 0. If I were to plot these, notice that 9, negative 4 is right here, roughly, and negative 1, negative 4 is right there. This one is a horizontal line. So horizontal lines will have a steepness. It just has a steepness of 0. It's between the negative and positive slopes. Pause the video and write down anything you need to. Okay, so now we're ready to write the equations of linear functions based upon their graphs. So what we're going to do is we're going to write the equation using function notation. We're going to have to find out, is this line easy to write in terms of the slope-intercept form, or is it easier to write in terms of the point-slope form? To do that, what we're going to do is we're going to look at the point that is on the line. So f of x is from here to here. We're going to find the equation of that line, and notice it has point A on there, which is on the y-axis, which is really nice. Okay, so all we need to know is just the slope and the y-intercept, and we can write the equation from there. To find the slope, we're going to use any two consecutive points and find out. So since it's going up to the right, it's going to be positive, and it's going up to right 3, which means the slope of the function f is going to be positive 2/3. So the slope is positive 2/3. This also has a y-intercept at 5. So I can simply write its equation as 2/3 x plus 5. Okay, let's look at g of x. For g of x, we have point B. Notice it has none on the y-axis, and if I were to look back at the y-intercept, it doesn't look like it's going to be a nice integer. So I'm not going to be writing this in slope-intercept form. I'm going to be writing this in point-slope form, and then we're going to rewrite it so we can write it as a using the function notation. So we got to find the location of point D, which looks to me at positive 4, negative 3. Okay, so point B, 4, negative 3. And if I'm looking at that line from point to point that's on there, it looks like it's positive slope, but it's going up to the right 5. Up to the right 5. Which means the slope of that line is going to be positive 2/5. Now if we were to write this without function notation, what we would do is we would write it using the y minus k is equal to m times x minus h. So remember, you have to change the sign of those coordinates that you are going through for the h and for the k into the formula. And the slope goes in front of the parentheses of the x's. So I would write this as y plus 3 equals parentheses 2/5 x minus 4. 2/5 in front of the parentheses. So y plus 3 is equal to 2/5 x minus 4. I want to write that using function notation, so I need to get the y by itself, so I'm just going to subtract 3 from both sides, which gives me 2/5 parentheses x minus 4 minus 3. Don't worry about distributing through those parentheses. Let's leave it as is, because if I were to distribute to the 4, notice I'd have negative 8 over 5, and that would not look as nice as this. Let's look at equation C, which is h of x. H of x goes through point C. Again, that's not going through the y-axis at a nice point, so we're going to have to use the point slope form. It looks like it's at -1, 8. Okay, so I'm going to write that down. C is located at -1, 8. And this one looks like it's a negative slope. Okay, so I just got to find out how far down and how far over I'm going. So down 3 over 4. So the slope is going to be -3/4. Okay, and if I were to write that in point slope form, I would do y minus the y coordinate, which is 8, is equal to -3/4 parentheses x minus the x coordinate, so it's going to be x plus 1, because the x coordinate is -1. Change the sign. But again, we're dealing with function notation, so you have to add the 8 to both sides. Oh, I'm trying to zoom in, sorry. -3/4, x plus 1 stays the same, but then it's going to be plus 8. Okay, and there's your function h of x. Now let's look at function p of x. P of x looks like it goes through point D, which is on the y-axis. That's a nice one. So that means that we have a y-intercept of -3, and the slope looks like it's negative because it's going down to the right, down 3 over 1, so -3 over 1. So the equation for p of x is -3 over 1x, which you can write -3x minus 3. There's your function for equation for function p. Lastly, let's look at r of x. R of x looks like it goes through point E, which is not on the y-axis. This one does have a nice y-intercept, but we're going to use point E just as practice. Okay. So you could write this in slope-intercept form because there is a point on the y-axis, but we're going to use point E, which is located at -9, -3. And looking at the graph, it's a positive slope going up to the right, so it's going up 1, 2, 3, 4, 5 over 3. Up 5 over 3. So if I write that using the the point slope form, it would be y plus 3 is equal to 5/3 parentheses x plus 9. To get in function notation, I got to subtract the 3 from both sides. So I have 5/3 x plus 9 and parentheses minus 3. Okay. Pause the video, write down anything you need to before starting to work on your assignment. Okay, so I want you to use the remainder of class today to start working on assignment 5.3. I will be collecting at the beginning of class tomorrow. You may work together on your own, but just make sure it's completed by tomorrow's class. I will collect them. Thank you.